Okay, now we'll say about the capacitor. There are some parameters in this chapter. First is capacitor in use, and then energy stored in capacitor, and then we'll see what if capacitor uh, arrange series or arrange parallel, or you can say uh, capacitor network. And the last one is charge and discharge capacitor. For the first, we will see about capacitor in use. Okay. Capacitor is using to store energy. Okay, so we can say it's a function. Is to store energy in electrical electro circuit, electronic circuit. Yeah. So capacitor function or capacitor is used to store energy in electrical or electrical circuit. Nah, and then kira-kira uh, bentuk kapasitor itu like this ya. Nah, di sini ada some part of capacitor. Terus let's say lead, lead connected to metal plates. Okay. And then there is metal plate. There are two metal plates here, left side and right side. And then there is the electric. Maybe the electric is any term. The electric is insulating material, insulating material between two plates. Kira inilah bentuk dari capacitor. And next, as the function is to store energy, how the energy can be stored in this stuff ya. Yang for the first, we'll see here about how to move charge onto plates of capacitor. Nah, kita tadi this two plates. Okay. Now, the first, this is shell plates, and then it will be connected to power supply. Okay, or voltage supply ya, like the voltage supply and be like a battery, and then untuk for what this capacitor connect this plate connected to power supply. When connected to power supply, okay, uh, this this negative terminal will push electron, will push electron here, will push electron here. So the electron will be stored here. Okay. because this black electron, it will be negative. And then the electron in other plates, electron yang ada di sini, itu repelled by this electron. Yeah, we know that like a magnet, yeah, with the same form itu akan repel. Jadi elektron di sini will repel, sehingga elektron in second plate ini, ya, kalau di left plate ini akan habis, akan berkurang, sehingga this plate will be positive. Okay, so it will be positive, and this electron stored in this in the right plate. And then it will be stopped if potential difference equals to EMF, electric force. In this in that condition, we call it the capacitor fully charged. And then okay, now we have two plates with has equals charge, yeah, but this charge this is full of negative and this full of positive. But the total of charge in this capacitor is zero when the condition charge storm. Now, and then ketika digunakan, jadi ini di connected to LED, and then nah the electron will be flow. Yeah, the electron will be flow here. So when the electron flow, the electron will be decreased in this plate. Yeah, in the condition we call it discharge capacitor. Yes. So how to charge capacitor again? Yeah, we connect it to power supply again. And next, we call it capacitance. Okay. What is capacitance? Capacitance. Okay. Capacitance is a ratio of charge stored to the potential difference proceeding. When we talk about charge store, when capacitor charge, this is equals ya. Jadi dibilang total charge-nya zero, tapi kenapa di sini bisa dibilang ratio of charge? Nah, di sini charge yang dimaksud itu adalah total charge in each, ya, total charge in each plate, ya. Total charge of in this negative plate or total charge in positive plate, not total of two charge two plate ini, tapi number of charge in one plate. This is we call it charge-nya. If we and then in equation we then write capacitance is C is charge, and the charge key over V. V is potential difference. P is charge, and then V is potential difference, and then C is capacitance. Charge in column, this anyway is 4, so the capacitance is column per 4, or it equals to farad. Okay, so we can rewrite this in form Q equals to C times V. So this is capacitance. And for example, calculate the charge a 220 microfarad capacitor charge up to 15 volt. Give your answer in micro coulombs and in coulomb. Now let's see this. So we know here charge is 220 farad microfarad. So it's equal to 220 times 10 power minus 6 farad. And then the charge up to 4 voltage or potential difference is 15 volt. So uh, sorry, calculate the charge, okay, on 220 farad capacitor and charge up to 15 volt. Give you answer in microcoulombs. So in this part, we will calculate charge scheme, and the capacitance is 220 microfarad, or equals to 2.2 times 10 power minus 4. And then volt is voltage or potential difference, V equals to 15 volt. So the charge equals to C times V will be 2.2 times 10 power minus 4 for C, and then times 15 for potential difference. So it will be we call it, and we 2.2 times 15 is times 10 power minus 4, or is 3.3 times 10 minus 3 columns, and it's in column. So if you want to make a column, 10 power minus 3 times 10 power 10 6, 10 power 6 microcolumn will be 3.3 times 10 power 3 microcolumns. This is about capacitance. Next, we'll see about the factor affecting capacitance. In equation, or factor affecting capacitance. So, that is the method length. Okay. This is the, the area of metal plate. That is metal plate has an area and has a distance. That is distance L and then A. So if the metal plates are larger, uh, it it will be increase the electron stored here when the capacitor charge. So it's proportion. Okay, so it will directly proportional with A, and then with L, if the length is will yang kecil di sini, the length is L, so the electron will be easier to move. So if the length is too long, the electron will be hard to move. So you can say it will be uh, it, it will be in the L. Okay, so the C A over L. Now C equals to A over L. There is a constant here. And the constant is E epsilon O. And the epsilon is permittibility. And then the constant is 8.85 times 10 power minus 12. Okay. If jika di sini on air or petrol, and for if there are a material here, so the equation for C equals to epsilon O times epsilon L times A over L, which the R is permittibility of that material. Setiap material pasti punya permittibility yang different satu sama lainnya ya. And then the last one, maybe you see the circuit symbol in circuit symbol for capacitor. In electrical circuit, the symbol will be vertical line and two parallel line that has same length and vertical. This is the symbol of capacitor.